Opened in 1891, the University of Texas Medical Branch at Galveston is the oldest medical school in Texas. Covering 85 acres and supported by over 13,000 employees, UTMB includes 7 hospitals, a network of specialty clinics, numerous research centers and institutes devoted to advanced research, a medical library, schools of nursing, health professions, and biomedical sciences, in addition to a medical school of 2,500 students and over 1,000 faculty members. The University of Texas Medical Branch's Ashbel Smith Building, affectionately known as Old Red, has played a vital role in the history of UTMB. Designed by the renowned architect Nicholas Clayton, completed in 1890 and built in the Romanesque Revival style, its colorful nickname comes from the materials it is made from: red pressed brick, red Texas granite, and sandstone, and it is listed on the National Register of Historic Places. Old Red truly earned its landmark status by surviving the Galveston hurricane of 1900, one of the worst natural disasters in U.S. history.
Prior to the 1900 storm, Galveston was the economic center of Texas. This was the place to be. This is where business happened. This is where it was effectively an Ellis Island of the Gulf Coast, and this is where immigrants landed, and that's really drove the expertise that University of Texas Medical Branch has in the area of research of infectious disease. And we have a long and tremendous history of critical research in that area and education of healthcare providers. Recovering from Ike required a new master plan and required a new approach to what we were doing. You know, the story that we like to tell is during the Great Storm of 1900 on Galveston Island. When that storm hit, the president of the institution at that time sent to Austin that there had been flooding in the medical school and that we ought to shut down for this semester. And the chancellor of the institution promptly wrote back and said, the University of Texas stops for no hurricane. Prior to 2008, many years we had had hurricanes and had planned for hurricanes and had exercised that plan and thought we were more than ready. Well, in 2008, Hurricane Ike proved us wrong, and that exactly what anybody who deals with infrastructure knows is that when you have events, they're never what you plan for. They're always different. And so in 2008, Hurricane Ike hit the island of Galveston with 20-foot walls of surge, completely destroyed the infrastructure of the University of Texas Medical Branch, and took the institution out of service for well over 90 days. One of the critical elements of that was we took a level 1 trauma center out of service for this region. Having learned a lesson from Hurricane Ike and that what happened wasn't what we planned for, we had to back up as an institution and rethink about what we were doing and what did we really want. What we wanted was we wanted to be resilient, and meaning that we're prepared for any event because you cannot plan for all events. This time it was surge, next time it might be wind, it might be fire, it might be a broken water line. There are all types of events, so the direction we were given was to make the institution resilient and able to return to service. That solution was really based on a mitigation plan for the institution as a whole. It consisted of 3 parts. First and foremost was elevation of our facilities. We knew that the seawall protected us to an elevation of 15 foot. We decided, based on a study that was done, to have a mitigation, an elevation of about 25 foot above mean sea level for all new facilities, and all critical elements of our existing facilities would be protected to an elevation of 20 foot. That plan included 15 megawatts worth of on-site generation. It included the replacement of our underground steam distribution with a hot water distribution system, and it included implementing the mitigation and elevation strategy of all new facilities being at a minimum of 25 foot above mean sea level. And then all of our existing infrastructure, we began an immediate project to elevate all critical elements above 20 foot.
Elevated 30 feet above ground level, 40 feet MSL, the new 7.5 megawatt East plant includes two 3,550-ton electric centrifugal chillers, a 5.5 megawatt gas combustion turbine, a 2 megawatt condensing extraction steam turbine, a 75,000 pph heat recovery steam boiler, one 1 megawatt diesel engine-driven black start generator, and 2 million gallons of chilled water thermal storage. Adjacent to an existing 10,000-ton chiller plant, the new 6.5 megawatt West plant hardening includes a 5.5 megawatt gas combustion turbine, one 1 megawatt diesel generator, a 75,000 pph heat recovery steam generator, and a 2 million gallon thermal storage tank. The entire existing plant, CHP, and thermal storage is protected by a 14-foot, 20-foot MSL flood wall.
The second part of our mitigation was to get rid of a direct buried steam system. We had a direct buried steam system that when the island flooded and that system collapsed, it pulled water into that steam distribution system, and it took us over 3 months to recover that steam system. We are now at the stage of that plan where we have the 15 megawatts worth of generation in place. We've actually just went through the first real test of that system in Hurricane Harvey. It proved a number of the elements of the design that we hoped it would. We proved the ability to switch fuels. We lost municipal electric supply. We were able to continue using our self-generated electricity on natural gas. That fuel switching is exactly part of the plan and worked very well for us. Today, the Thomas Mackey Water Plant, which is part of the Gulf Coast Water Authority, had to shut their plant down, shutting off total supply to this barrier island of water. Our plan included 4 million gallons of thermal energy storage tank. What we thought was unique about our application of thermal energy storage is we lined up the system to also be used as an emergency supply of water for our cooling tower. So we have 4 million gallons of processed water available to us that before the event of Ike we did not have.
AEI analysis determined plate and frame heat exchangers to be the most cost-effective and energy-efficient option, with a maximum system delta T for the nearly 40 buildings converting from steam to hot water campus heating distribution. The conversion utilized existing building piping to serve thermal and domestic water heating loads. 10 lab and research buildings retain steam. The new hot water distribution system connects the two plants to buildings throughout the campus with over 5 miles of piping, direct buried wherever possible. To counter Galveston Island's high saltwater table, acidic soil, and flood-prone location, AEI selected a highly corrosion-resistant, factory-insulated, and steel piping system with high-density polyethylene outer jackets that complies with European standard EN 253.
One of the requirements of the university was not only for this to be resilient, but to make good business sense. And when you have 15 megawatts of grid-connected capacity in a deregulated market, you can take advantage of economic dispatch. And when the grid is suffering, or when there's a shortage of capacity, or there's an unexpected outage, and real-time market prices we've seen go as high as $2,000 or $3,000 a megawatt hour, our ability to not only take load off of that grid, but actually dispatch into that makes a tremendous amount of economic sense for the institution. We're prepared to be able to run this institution's air conditioning for an entire week without municipal supply. At the end of the day, while our infrastructure was completely destroyed to the tune of over $300 million worth of damages during Ike, at the end of the day, we've restored that infrastructure. We're grid connected, we're 40% more thermally efficient, and we have the ability to economically dispatch our excess capacity. That's a tremendous leverage position for University of Texas Medical Branch, and has worked very well for us to this point. You can never plan for everything. So what you can plan for is to be as resilient as possible, and that's what we believe we've done.